Hi, boys and girls.
Hello, 8th grade. Today we're going to be having fun with acids and bases. Now, I want everyone to think, if you were given the choice to eat an orange or a lemon, which one would you choose? Please make a note of it on your worksheet that you're filling out. Think about the characteristics of both. Does your mouth water when you think about a lemon? Why is that? Which one do you think would taste better?
All right. Today we are going to be talking and learning about acids, bases, and the pH scale. Now, many of you may be thinking, excuse me, Miss Waltmire, what is an acid? What is a base? What is a pH scale? So hold on, we're learning. So first, I would like you to know that acids and bases are chemical properties, which we have learned about previously, but they are also chemical reactions. Now, chemical reactions can occur when certain conditions are right within the environment. Now, I'd like you to realize that chemical reactions are dependent on a few things. So, on your piece of paper that you're filling out for notes, you're going to be having different blanks, and so you need to make sure you're following along because this will be very helpful in our activities for tomorrow. Now, chemical reactions are dependent on the energy availability in the environment. This is also dependent on the energy involved in the actual substance or the liquid or the solid, anything that's causing the chemical reaction. Now, it's also dependent on temperature, and this plays a big factor in the reaction, as well as the pH level of the internal or surrounding environment. Now, please highlight, underline, do whatever you can for pH level because this is going to be the basis of what we're going to be talking about.
So, you guys may be thinking, pH level, what is that measured on? This is called a pH scale. It ranges from 0 to 14. Solutions that are more acidic range from 0 to 6. 7 is neutral, and then 8 to 14 are bases. And I want you all to note that pH scales follow a 10-fold change per number. So this means that a solution that is at 1 and a solution that is at 2, the 1 is 10 times more acidic than the 2.
So, what is an acid? Try to think about times that you have heard the word acid before and just keep that in your mind while we're learning about these things. Now, an acid is a solution with excess hydrogen ions. Now, hydrogen, in your parentheses in your notes, you want to make sure you write a capital H and a positive sign because that is the written representation of a hydrogen ion. Now, the Latin word acidus is where we derive the word acid. And acidus means sharp or sour. And these are properties or characteristics of an acid. Just think, like that lemon, it's nice and sour. And the more hydrogen ions that you have is the more acidic that your substance or solution is going to be. So on our pH scale, the more ions, the more acidic you get. Now, examples of an acid include vinegar. You think about that has a sharp, sour side to it. Now, it also includes citric acid. These are found in lemons, limes. Are they found in oranges? I don't know. We will have to see. But it is also acid substances are also in ascorbic acid, which is where we derive our vitamin C, and that's essential for our body to function. There's also sulfuric acid, and these substances you will find in fertilizers or maybe paint or different plastics, wide variety of acids, even including car batteries. For those of you that, are anxious to drive, you may be using forms of acid.
So next, let's think, what is a base? A base is a solution with excess hydroxide ions, and you're going to want to note that hydroxide is O, H, and then a negative sign. And look at the word hydroxide. It has hydro and oxide. which forms the O for oxygen and the H for hydrogen. And bases are also referred to as alkali. You'll hear base and alkali kind of interchanged throughout the lesson. Bases can also accept hydrogen ions, and they're often slippery, bitter, or corrosive. And some examples of this is soap. And another one is ammonia. I don't know if anyone has ever smelled ammonia, but it's very, very bitter. Another one is baking soda. And I want everyone to think, if baking soda is a base and vinegar is an acid, what happens when we combine them? A chemical reaction happens. Other bases we have are chalk, oven cleaner, your blood, and the plasma inside of your blood.
Now, as you can see, there are so many examples of acids and bases, and they all fall on the pH scale. The pH scale is what measures the amount of hydrogen ions, the amount of hydroxide ions, and these are seen all throughout our environment and affect our very lives. So we are going to focus on how acids and bases affect our environment. For instance, we use acids and bases in cooking. For instance, the vinegar, the baking soda, the reactions with the enzymes and the hydrogen ions and the hydroxide ions, they all play into the chemical reaction that happens with the water you're cooking with. So there's going to be these different substances and solutions while you're cooking. There's also going to be acids and bases with cleaning liquids. For instance, dishwasher soap or laundry detergent. There's different pH levels for these substances. There's also going to be acids and bases with making computers and even our batteries, like we mentioned before with car batteries.
And then another one is acid rain. So the water that collects in the clouds that then falls down as rain, that has a certain pH to it. And if it is too acidic, it's known as acid rain. And it can be very damaging to plants, animals, and their environmental habitats. And the last one, which I thought was very interesting, is digestion. So even in our own stomachs, we have acids and bases working to break down the foods that we eat.
All right, boys and girls, so we have wrapped up the lesson for you to watch this evening. We want to make sure that you have your name on your paper, all your notes filled out, because these are going to be essential tools while we work on our activities in the classroom. We have different variety of activities. We have an exciting experiment, which we are glad for you to be doing, so be prepared.
We'll see you tomorrow.
We'll see you then.
Bye.
Bye.